Here we have our usual primal dual pair of linear programming problems P and D. Let B be a basis, determining the basic feasible solution X star. Recall that the way the simplex method detects if X star is an optimal solution is as follows. It first solves for Y star in Y star transpose times A sub B equals C sub B transpose. And that gives Y star transpose equals C sub B transpose times the inverse of A sub B. And checks if Y star satisfies Y star transpose times A sub J, which is the jth column of A, is less than or equal to C sub J for all J not in B. And that means Y star is feasible to the dual problem D if this is true. And if this is the case, the simplex method will declare X star to be an optimal solution. In other words, if a basis B satisfies both of the following, the first is B determines a basic feasible solution, and the second is Y star satisfying Y star transpose times A sub B equals C sub B transpose is feasible to D, then the simplex method will recognize optimality in the first iteration. And a basis that satisfies both 1 and 2 is called an optimal basis. Now, of course, it is possible for bases to satisfy 1 but not 2, or 2 but not 1, or neither. And a basis that satisfies 1 but not necessarily 2 is called a feasible basis. And a basis that satisfies 2 but not necessarily 1 is called a dual feasible basis. Note that the simplex method works with feasible bases throughout. However, there is a method called the dual simplex method that works with dual feasible bases.